Hey, welcome back. The local lathe shop dropped by my place and they handed me a handful of these double-ended carbide grooving inserts. These are made by Arno. Very similar style is available from a lot of other places. You can get them in straight, you can get them in full radius and some other profiles. And the holder for it looks like this. A very standard piece. I think it's a 25mm shank. The guys run fairly well-sized Mazak lathes, Y-axis CNC lathes. He came to me with these because he has a problem. He needs these inserts with a 1mm corner radius on both sides. The particular feature he is cutting is in such a shape so he cannot use a narrow insert and just do a 2-axis interpolation of the radius. And the supplier doesn't have these inserts with a 1mm corner radius in stock, and he needs them kind of soonish. So he figured I could grind him a bunch of them. And of course it's the weekend, and on a Sunday I usually don't have anything better to do. And I played a little bit of grinding accessory Lego and I came up with a little bit of a setup. First, I needed a way to hold these inserts because I don't have a good way to hold a 25mm shanked tooling on any of my grinders for what I want to do. So I took a piece of 20mm drill rod, and all this was done on a manual mill. Split it down the middle. This flat surface here is exactly on center of rotation. This will be important later. Then I cut a little bit of a step clearance here. And this middle slot here is also exactly on center line, which it would not really need to be, but it's easier. And this slot is exactly the same width as the body of the insert. I had to die grinder a little bit of additional clearance on here on both sides, these radius ends, because the body of the insert is smaller than the cutting portion. So insert drops in here like this, and how it's held in position is a very primitive way of doing it, just with 2 M3 screws. And the heads of the screws just pinch down on the insert. That way the insert is held in place fairly decent for a little bit of grinding. One important thing is, how do we adjust the stick up? I think by now you understand where I'm going with this. By putting the insert in here, and rotating this whole fixture, I can grind my radii here. I can come in with a grinding wheel like this and grind my radius here. 2 adjustment problems, of course. I need a side-to-side adjustment because the radii, the center of the radii are offset from the center line. This adjustment I can do in the punch grinder that I'm going to use, the spin fixture. But this adjustment, this has to be set manually. And that's why I milled this flat surface here. If I put something on this flat surface and I just bump the insert up against it, lock it, then my insert, the front face of the insert is exactly at center of rotation of the fixture. Doesn't help me here very much. Since we're grinding a 1mm radius, we want it to move over 1mm like this. We could either do it with an indicator, or what I figured would be easiest, use a 1mm gauge block and a second gauge block run to it to get my 1mm offset here. Then I just push the insert up against the gauge block, lock it, double check it, lock it down firmly, and walk over to the surface grinder. Once it's set up on the surface grinder, I only have to swap out the inserts. This stays in the punch grinding fixture. So let's walk over to the surface grinder. That's my setup on the surface grinder. I have a large box parallel here on the magnet, and parallel down here to space the punch grinding fixture, which is set to spin freely. On top of it, this is needed to clear the piece of spindle of the punch grinder that sticks out the back. These are kind of annoying to mount laying flat. Sometimes you can hang them off the side of the magnet, but in this particular case I'm running out of travel on the wheel head to go to the side because I'm using a cup wheel for grinding here. So the fixture drops in like this, held in the V-block. And I'm indexing at 90 degrees. Now I'm using a dial test indicator to indicate the fixture to be in line with the travel, just by rotating it very lightly. To make my life a little bit easier, I'm going to use a toolmaker's clamp on here. First of all, so the fixture doesn't drop down, and secondly, that I have something to hang on to adjust the rotation. Sometimes it's little things like this that people do but not mention that make your life setting up machines so much easier and so much more convenient. So let's hang a magnet base here, dial test indicator. Okay, now I can just traverse the table back and forth and see how much I'm deviating from being true to the travel. I think I need to go this way. Okay, this doesn't need to be like micron accuracy. Half micron will do fine in this case. Let's zero it out again. Yeah, a little bit here. Okay, this is doing fine. Now I can lock the fixture in place. Get rid of my toolmaker's clamp. Okay, now comes the tricky part. Another of the tricky parts on this whole endeavor. The overhang in this direction of the insert is set with the gauge block as I showed before, but we also have the sideway adjustment here that I can do with the rack and pinion motion of the punch grinder. How do we set this? Well, the overhang needs to be the same as in this direction. So I've dial test indicator here, and I found the high spot on the edge of the insert. Zeroed it out, clear the insert, rotate by 90 degrees. I set the stops down here to get a 90-degree motion, and then I just come in and I move the rack and pinion here to the same value as in the other direction. You have to sweep a little bit because the inserts with their chip breaker geometry and clearance angles are a little bit hard to find the high spot, but as you can see, nailed it right away. Snug it down. Don't go crazy on these. It's grinding equipment, not a mill vise that you need to drop down, which in many cases don't need to be grunked down anyways. So here we go. Both sides zeroed. Now we just make contact with the grinding wheel with the side of the insert, and grind our radius until we are getting a nice tangent contact pattern. From this side you can see the grinding wheel that I put on the surface grinder. This is kind of too small. It's running at a relatively small surface speed since this machine does not have different speed settings for the grinding spindle. This is a 75mm diamond wheel with a grit of, I think it's a D25, which is still an awfully fine grinding wheel. And most likely it will not run very true axially because I pulled this off my other grinder. But it will do fine. So I'm setting everything up in a way. Oh, by the way, I tilted the head of the grinder by 5 degrees to the side to get my clearance angle on the insert. Otherwise I would have to tilt the entire spin fixture 5 degrees. So in that regard, the BIMA grinder is really behaving a lot like a tool and cutter grinder because you have this tilting head that allows you to do a lot of things without a lot of effort. If I had to choose and could only have one grinder in my shop, it would be a surface grinder. I think I said that before. A surface grinder is the most universal grinder that you can buy. You can do surface grinding very good because it's made for it. You can do cylindrical grinding, which can also do very good because it's built very rigid usually. It can do tool and cutter grinding because usually you have a very large work envelope, and you can do any oddball work that you want to do because it's a nice, precise 3-axis frame. Tool and cutter grinders, real tool and cutter grinders like a Cincinnati No. 2 or a Walter tool and cutter grinder look more universal at first, and they often are because they have accessories like spiral grinding attachments and things like that, but they are a horrendous amount of setup and adjustment work. Surface grinders are in that regard really thankful machines. So I think that means don't buy tool and cutter grinders. Buy surface grinders. I snuck in the grinding wheel as close as possible to my fixture without hitting the fixture. If you ever wondered how I filmed something like this, well, the answer is simple. With a tripod. There's the Panasonic camera with a 24 to 70mm lens. Natural light, a little bit of additional lighting from the machine, and super cheap tripod, sandbag to weigh it down, another sandbag to weigh it down even more, and that's the entire setup. And yes, I know people built camera gantries and things like that to make filming seemingly easier, but I don't buy into that. Look at my ceiling. There is stuff all over the place on my ceiling, and there are shelves all the way up to the ceiling. And this would be a royal pain to put in a ceiling mounted system. Also, I don't like fixed built-in infrastructure like that for filming. I like to have my stuff highly mobile, and cheap tripod does the trick very well. One thing that I want to build is the Robin Renzetti articulating arm with a Mac base. That's different. That's a piece of beauty. Touch off on the side of the insert with the grinding wheel, zero out the DRO, and then we start to sweep our radius here. It's grinding a little bit in the fixture down here, but meh. I raised the grinding wheel a little bit, so this should take care of it. think that's it. So, dropping my gauge block stack in here, making sure it's nice and seated. And Stefan, why are all your gauge blocks scratched up? Well, because I do stuff like this with them. Shop floor gauge blocks kind of suffer in my presence. It's definitely time for a second or third set in my case. I have one set that I use for real ugly stuff like packing in a vise or things like that. That will definitely damage them. And I have a set for general gauging and setting stuff. That's this set here. But it would be wise to have a third set that's dedicated to metrology. Setting gauge block stacks for comparative measurements on the surface plate and things like that. Here's the insert set up. Time to grind another radii. I think I said it before, but I really adore these spin fixtures or punch grinder or whatever they are called in your part of the world. Stempelschleifkopf, it would be in our place. I really adore them for their utility they bring to a shop. They allow you to do cylindrical grinding. They greatly expand your tool grinding capabilities on the tool and cutter grinder. They do very precise fixed increment indexing. The stops here can be set extremely accurate with gauge blocks to do precise indexing. Also, they can be set with the direct indexing for tangent grinding like this. Super useful not only on grinders, but also I used it as a fourth axis on my CNC mill or as an indexer on any of my milling machines in general. Because they're relatively small, you can just chuck them in a vise and go from there. So highly liked piece of equipment in my shop, very precise. This one is made in Taiwan by a company called Jin Tech. And they're really making very nice spin fixtures. I just inspect them with a radius gauge against a light source. Would be neat if I had a profile projector or a measuring microscope with a quadra check that can check radii. Now I flipped the entire setup, well, the stops on the spin fixture 180 degrees, so I can grind the radii on the other side. And again, I started out by zeroing the dial test indicator here on the front of the insert. Then I adjusted the V-block side to side in the other orientation to get my dial to 0 in this orientation too on the high spot. Yeah, it's 10 microns, 10 to 15 microns off, but this is a corner radius in a relief cut, so we're not crazy concerned about it. It's well within the standard tolerance for a corner relief radius. Orientation is really even harder to film because I'm constantly in the way of the camera. So insert goes in. Screws get somewhat tightened so I can still slide the insert back and forth like this. I can come in with my weirdly shaped gauge block stack, and I push the insert up against the gauge block like this. Tighten the screw, and that's the setup. Once you have to do more than one with the setup to grind radii, it really pays off compared to, I could also just freehand grind and lap these radii on a fine diamond wheel and check it with a radius gauge, but doing more than one that way would be highly annoying. So that's the reason why I did a little bit of setup here. Excellent. What I just did is I removed the cutting edge, the side cutting edge, from the second side of these inserts. Problem with them is, let's say you're cutting on this side into a piece of round material, and when you cut deeper than to this point here, the second cutting side or cutting edge of the insert will scratch up your sidewall finish, and that looks like poop. Since this insert with the two radii has to cut up to a shoulder, on the right side we removed all of the cutting edge here to be flush with the body of the insert. Okay, here are the 3 inserts plus the 4th one already installed in the holder. Unfortunately, I do not have a good way to test these inserts with this holder because none of my lathe doesn't take 25mm tool holders. I would have to remove the quick change tool post and strap clamp this holder directly to the compound, and that's a little bit more effort than I'm willing to put in. I'm very confident that these inserts will cut perfectly fine, and the radius that we ground onto there is fine. It should do perfectly its job. I hope you enjoyed this little tool grinding, tool modifying project, and goes to show that surface grinders are really versatile machines, especially in combination with punch grinding fixture. I wasn't able to be on site when the customer cut the parts, but he sent me some pictures of the feature that he cut with the radius grooving inserts that I ground, and it worked out perfectly fine to his account, and everybody's happy. So another one in the can. Hope you enjoyed. Thank you all for watching, and I'll be back.